Welcome back, everyone. So hopefully you watched all of the SQL and database course. If you haven't, I'm hoping you at least watched the recommended sections, because here on out, I'm going to be referencing some of the high-level concepts that you learned throughout those sections, but also I'm going to cover a refresher of what's important and also what additional things you need to consider when thinking about system design from the context of databases. So to begin with, we want to talk about CAP theorem. Now, CAP theorem is essentially a way to think about distributed systems, particularly your databases, and what types of databases to choose for what kind of solutions that you have regarding your data. So to begin with understanding CAP theorem, we need to understand the C, A, and P stand for different things. The C stands for consistency, the A for availability, and the P for partition tolerance. Now you'll notice that there is an overlap between two of any of the three circles. The reason for this is because your system can only be two of these three things. So you can have a system that is consistent and available. You can have a system that is consistent with partition tolerance, and you can have a system that is available with partition tolerance. The thing I want to talk about, though, is that generally speaking, in almost all of your systems that are distributed, it is always going to at least have partition tolerance guaranteed. Now, we're going to talk about why you can only satisfy two of these three things, and it's really contingent on the fact in a distributed system that you have partition tolerance. Now, what is partition tolerance? So when you think about a system that is distributed, in order for it to distribute it, it implies that there are multiple nodes or duplicates of your database or your servers or your overall system. And this distribution over multiple servers throughout the world or throughout different regions is what makes it a distributed system in the first place, meaning that much of your system doesn't sit on one node. If this is the case and it's split up, then this means that by nature, you have a distributed system that communicates to each other, these nodes, through networks. Now, if they're communicating to each other through networks, that means that if at any point these communications break down because the network goes down, then you have a partition. Now, this partition is simply the fact that you have a failure in your network or a failure in the communication between servers. If this is the case, then we can think about how the fact that in almost all systems, we cannot control whether our network goes down. So this means by default in a distributed system, you have to have partition tolerance, meaning that your system must consider the fact that partitions, i.e. the breakdown of communication between two nodes, is guaranteed to be possible inside of your system. So this means that with that in mind, you must consider partition tolerance one of the absolute requirements as long as you're talking about distributed systems. So this means that if we can only have two of these three in the CAP theorem, partition tolerance is guaranteed to be one of them, again, as long as you're talking about a distributed system. Now, the next one I want to talk about is consistency. What is consistency? So again, let's imagine we have our server. Or let's more specifically talk about our database, because we're really talking about databases with CAP theorem. With our database, we might have three duplicates. If we have three duplicates, let's imagine we're talking about something that is a financial institution application, or the database handles the ability to manage the actual amount of funds in different accounts for a bank, for example. Let's say it's a banking application, and that's what our database stores, the different users inside and their respective balances. Let's imagine that each of these three ATMs connect to a different duplicate of the database or a different node containing the database data. In this case, let's imagine that we have Sarah and she goes to one of our ATMs. And let's say that when she checks the ATM for her balance, the ATM communicates with this node in the database in order to identify that her balance is $1,000. Let's say Matt, on the other hand, goes to a different ATM, and this ATM communicates with this database to see that he has a balance of 0. In this context, in order for the data to be consistent, or this database to have consistency, let's say that you look at this data that we have now collected. Sarah with her $1,000 in her balance and Matt was 0. These values are distributed across these 3 different databases equally, meaning that each different database must hold the same information. If Sarah were to visit any of these 3 ATMs, she needs to see that her balance is consistent across these 3 databases, meaning that she has $1,000 no matter what ATM she checks. And because no matter what ATM she checks, each of these databases that they're respectively connected to must reflect the same balance, i.e., they must hold the same data. So with this in mind, let's say Sarah performs a transaction. And the transaction she performs is that she wants to transfer $100 to Matt. So this means that her transaction has 2 steps. The first is that we must take a credit of $100 from her account and then debit $100 into Matt's account, meaning that she loses $100 and Matt gains $100. So this transaction must go into this database that it's connected to. So Sarah's $1,000 goes down to $900 and Matt's goes up to $100. Now, in order for this database to be consistent, because remember, there are 3 nodes in our system right now, so there's 3 different database nodes that all must reflect the same value. If the data is inconsistent, then if Matt were to check inside of his ATM, even though Sarah has deposited $100 into his account from her account, because this database is not consistent, he will still see that his balance is $0, even though Sarah's database that she updated has reflected that there should be $100 in there for Matt. Now, we know that this $100 does exist in the actual database where Sarah made the transaction. But because our database here is not consistent, we don't reflect that. This becomes especially problematic for a financial institution, especially if Sarah goes to another ATM and she checks that database from that ATM, and because, again, the data is inconsistent, she sees that she still has $1,000. This means that she has not actually lost the 100 according to this database node. So now, if the system was consistent, what should happen is that Sarah, when she makes that transaction, that $100 gets debited and Matt will receive the $100. So these values work. But what will happen is that no reads can happen from any of these databases unless all the other databases also get their systems updated. So all these database nodes are communicating with each other, trying to sync the state now that a transaction from Sarah has happened, meaning that Sarah's new values of 900 and Matt's value of 100 needs to be updated in every single database node. Now, if Matt were to check, well, he'll see that he has the appropriate $100 because this has reflected. And similarly, if Sarah goes to any ATM in the system, she checks her balance, she'll see that she has 900. This is what consistency means, that all of the nodes in your database must reflect the same value of all transactions that happen. Transactions are not considered complete until all the database nodes hold the same value, meaning that your data is consistent in your distributed system. Because again, a distributed system means you have multiple copies or nodes of your database, and all of them must consistently show the same data, hence consistency. So that's what consistency is. Now, if your system is consistent and partition tolerant, then you have a CP system, hence that overlap purple area there. So that is one type of system. The other one is an available system, and that's what we're going to talk about in the next video. We're going to talk about availability and what that means in the same context of databases. I'll see you in the next video.